Good morning, everyone. Today's class we are going to see about lenses. For the past few videos, we have been discussing about ray diagrams or water waves, etc. that comes under light chapter. Today's will be a continuation of it, which is lenses. So, with today's session, we'll cover light chapter completely. Right. Now, in lenses for IGCSE curriculum, what you need to know about is the two types of lenses. What are they? Why are they called so? And also construction of ray diagrams. That's mainly about the whole of lenses chapter is all about. Now, I'll also be touching through the experiment that is conducted. It's part of unit paper 6. So you will have the entire session covered today. Now, what are the main types of lenses? Convex and concave. Why are they called so? Convex lenses is because the light rays coming through it will be converging or focusing to a point, but in a diverging lens, as the name itself says, the concave lens, the light passes through the concave lens will not come together, but instead they diverge. So if you remember these two terms, converging lens and diverging lens, you will remember the definitions. Now we'll see about how to construct or figure out the properties of an image that is formed by a convex mirror when you have the objects placed in front of it. We'll see. I'll discuss about two different positions. The rest you'll be able to manage it on your own. If you follow these steps, irrespective of the position of the objects, you'll be able to draw or construct the diagrams accurately, and you will be able to write down the characteristics of the images also accurately from the diagram itself. You don't have to by heart anything in this. Okay. So the steps are important. So if you know the steps clearly, if you're able to construct it properly, you can take it from the diagram and write down the characteristics. All right. Now here I have drawn a convex lens. Convex lens is one which is broader in the middle and tapered at the ends, and concave is just the reverse. Now what's the procedure for constructing a ray diagram? There are two properties basically of a convex lens or concave lens. The optic center, that is center of the lens, it has got a special property. A thin lens with the optic center, if you call that as say P. So through that point P, if any light ray travels, it will not bend or it will not refract. So that's a special property of lens. Through the optic center, any light ray traveling, it will go straight, right? Now another property of convex lens is any parallel ray, I repeat, any parallel ray that hits or passes through the convex lens will pass through the focal point on the other side. All right, first let's look into the common key terms that you'll be using in the lenses chapter. Is the focus or focal point. Also you might be using principal axis and focal length. All right, these are some of the key terms that you should be familiar with. Focus or focal point is, for a convex lens, the parallel light beam that approaches the convex lens will be converging, or they will all pass through the focal point. Okay, you have the diagrams given in the textbook, you can refer to. I hope you would remember that. It's not a difficult one. You have the parallel light rays, all of them will converge through, or they will pass through the focal point. That is your focus for convex lens. When we discuss about concave, I'll mention what it is about. The principal axis is something that is, it's like a perpendicular line, I would say, a perpendicular line that passes through the optic center, right? This line that I've drawn in the middle, that's referred to as principal axis. How would you define it or describe it? It is the line that is perpendicular to the lens, right? But it passes through the optic center. Now optic center is nothing but the center of any lens. The midpoint of any lens is referred to as optic center. Alright. Now these three are some of the terms that are referred to when you're, sorry, I didn't mention about focal length. Focal length is the distance from the optic center to the focal point, which means this distance. This distance is the optic center. That is from P to F. That's your focal point, focal length. So what is focal length? The distance from this, very important, not only in terms of definition, you should be able to locate which part or which section refers to the focal length while constructing the ray diagrams. It's very important, right? Alright, these three are from the ray diagram. Now while you're describing the characteristic of images, I'll give you some more key terms that you are expected to write, alright? Now we'll see how to construct the ray diagram. Now following the rule or the way convex lens behaves, all you have to do is just take two light rays, because for construction or finding the position of an image, you need to know minimum two light rays, or we have to construct two light rays that passes through the lens, and you will be able to construct it correctly. You can draw as many light rays you would know from an object. You will get innumerable number of rays, but for the construction, all you need to know is about two light rays from the same point, right? So usually we take from the tip of the object, so you can draw a parallel light ray. Now that has to reach up till the center of the lens. See, this dotted line may not be given in your diagram, or sometimes it's on the grid, so you should be able to position it. You have to bring the parallel light ray till the midline or the middle of the lens, right? After that, how will it behave? All parallel light rays should pass through the focal point, correct? So you need to connect that to the focal point. So extend it as much as you can till the grid is there, or till the edge of the page. That's easier, you can save time later on. So the first light ray parallel, it has to come till the middle of the lens, and then it passes through F. Then the second light ray, as I mentioned earlier, you connect the optic center and the tip of the object. Okay. Now what's the speciality of this? Will there be any deviation? No. As I mentioned earlier, through the optic center, any light ray at any angle it passes, it will pass through straight. Okay. So you don't have to think about anything. Just connect these two and extend it. That's about it. We have finished the construction. That's how easy it is. So two light rays, one through the optic center, just constructed straight. The other one parallel should pass through the focal point on the other side. Now construction is over, but if they ask you to describe the position of, or describe the characteristics of the image, then what do we do? Now for that, what you have to remember about the key terms is diminished or magnified, inverted or erect, yeah. So these key terms you are expected to use: diminished or magnified. What are the terms, the meanings of the terms? Diminished meaning it is smaller than the object. Magnified is understood, it is bigger than the object. Now inverted, it's upside down. Erect, it is straight. Alright, these terms actually you can describe it in your own words, but these are the key terms that will score you probably better marks. Okay, now this is the meeting point. So since I have started with the tip of the object, this meeting point represents the same point of the image. Alright, the same point of the image. So the arrow is here. You have to always drop or finish off the object till the principal axis. So don't leave it like this here. You drop it till the principal axis. So this now object is here. This is your image, right? So from the construction, if you look at the image, so what you need to find out is, or what you need to describe is, using these terms, what are the characteristics of the image? Now the first one, is it diminished or magnified? How will I identify? You just compare the size, the length of the object with the image. Now here you can see it is smaller. So in this case, the object is diminished. Got it? So it is diminished, and it is on the other side. So the arrow is down. So it denotes that it is inverted. Right? So two characteristics of the image we have written: it is diminished and it is inverted. Now two more characteristics you can include or add on is, where is it formed? Now this is formed between F and 2F on the other side of the object. The object is here, image is formed on the other side. So you have the object image formed on the other side of the image, other side of the object, sorry. And where exactly is it formed? Beyond F on the other side, beyond the focal point on the other side. Now, so that's your position is your, excuse me, third property. Now the fourth property is real or inverted. Okay, so this is first characteristic, second one is this, third one is position, fourth one is real or inverted. Now, as I was mentioning earlier, when you're constructing the ray diagram, you will be able to identify the four characteristics. First, what is the size of the object. Second, how is it, whether it is erect or inverted. Third, the position. Now, the fourth one is real or inverted. Now, how do you identify from the diagram? It is, see here, the two light rays have actually met on the other side. Okay, the two light rays have met on the other side. Such cases, the real image, it is actual light rays meeting point, indicates that a real image is formed here. You can capture it on a screen. Getting it? I'll discuss the other one. The second one, you will notice the difference. Okay. So that's about it. So the characteristic for, see, where did I place the object? It is between F and 2F. Alright, the object is between F and 2F. I constructed the image and I have picked up four different characteristics for the image by looking at the image itself. Okay, there's one example. In the next video, I'll discuss about a different position of the same convex lens. See you in that video.